Hello everyone. As you all are aware, Hive is a data warehouse built on the top of Hadoop. Hive supports two types of queries. One type of query is a simple fetch, and other types of queries are those with some aggregation functions or a filter predicate. Those with aggregation functions and filter predicates necessarily are going through MapReduce in Hive to fetch the data, whereas simple fetch queries like select star etc. will not be using MapReduce. Often when you are creating your warehouse on the top of Hive, it might be required that you need to get the latest snapshot or latest data from Hive so that you are consuming front-end application or some other downstream applications can use the latest near real-time data from Hive. One thing is you can do that by just writing a JDBC application which is connecting to Hive, but every time you will have to make a query manually in order to get that particular data. So here I'm using a very simple trick, Google's Guava Cache, and I'm going to set a time interval of 20 seconds to fetch the new data from the Hive table so that if there are any changes to your Hive database, automatically I am letting the Guava Cache to reflect that changes every 20 seconds. So let's start. Open your browser and go to foroursun.com/passion where you will see a lot of code examples, and take the code with the name Hive Cache Cloudera.tar. This particular implementation is specifically targeted at Cloudera VM 513, which is running in my machine. It is 5.13.0. So if you are porting this application, I will tell you what are the changes that you may need to make. So click on that file and make sure that it is downloaded onto your downloads folder. So this is the file, right? And then click on save file. And let's open a terminal and let's move that file to our home directory. So move, downloads, Hive Cache Cloudera.tar to dot, which is the current directory, and then do a tar to extract it with the command xvf. You can automatically see that it created a directory called Hive Cache. So go to Hive Cache, and I'm using a Maven based build. If you're not familiar with Maven, please look at Apache Maven. Better than Ant. Ant requires the entire lib jars to be downloaded, whereas Maven, if you have an internet connection, will connect it and bring all the dependencies that you specify in the pom.xml. POM stands for Project Object Model. So in my pom.xml, I have some dependencies, and these dependencies, as you can see, are on Hive version 1.1.0, and it leverages the Hadoop client 2.6.0 and Hadoop common 2.6.0. The reason is these are all the versions that we have currently for this 5.13 virtual machine, freely downloadable from Cloudera website. I can show you that if suppose you type the command Hadoop version, you will see that we are using 260 major version, leave the remaining portion. Similarly, if you type Hive version, you will see that we are using Hive 1.1.0. So these are the two values that are coming into the pom.xml that you have seen a bit earlier here. So if you are porting this particular application to a Mapper Hadoop or Hortonworks Hadoop or any other version, please change these dependencies depending upon your Hive and Hadoop versions, right? Once that is done, let's go to source to give you a brief explanation of what we have done here. So I have got two files. One is called hiveclient.java and cache-test.java. The hiveclient.java is a very simple JDBC program to connect to Hive and get the result set. As you can see, we start with the driver name and then we register that driver. In the earlier one of the demos, I missed writing this particular line. That is why I was getting an error. So please make sure that you are registering your driver. This is standard for any JDBC program. And then you are connecting to your Hive version that is running in Cloudera. So I am running JDBC:hive2/localhost 10,000/default. Default is the default database. And by default, Hive is a username. You can leave it empty or give your password. Right? So that creates a connection to Hive, provided you already started your Hive server 2. Hive server 2 will start the JDBC thrift server to connect to Hive and make sure that Hive server 2 is running, right? You will see a prompt if Hive server 2 is start running, otherwise you will get an error. So here I got the prompt back, which means that in the background it is running. You can also check Hive server 2 status to see whether it is running or not. Alright, now what we are going to do is inside this get dynamic result set function, I am returning a class. This class name may be a little bit new to you, and let me explain you what does that mean. Normally, whenever you are creating the query, you get a result set. RS is my result set. This is a class that is provided in java.sql package, the result set class. But if you open another command prompt and if you write the command serial version of java.sql.resultSet, you will see that result set is not serializable. What does that mean? If a class is not serializable, then the instances of that particular class cannot be traversed through network. In Java, a marshalling and demarshalling of objects are necessary. Serialization or deserialization in other way is required whenever you traverse an object through the network or you want to persist it. We are going to use Google Guava Cache, and if you want to put something inside the cache, that particular object or instance must be serializable, which means that this particular result set, if you use like this and put it into the cache, we will get an error telling that it is not serializable. So we need to convert the result set into a form which can be serialized and deserialized, and that is where rowset dyna class is coming, which is coming from org.apache.commons.beanutils package. It's open source, and in Maven dependency you can see that I am depending upon common beanutils class. So this particular function returns a serializable object, and what we are going to do is the other file in the cache test.java, we are going to get it and put it into cache. So you can see that the way in which I'm creating a Google Guava Cache object, we are using the loading cache instance by creating a new builder or static method of the cache builder factory class, and you have to write some methods, and inside one of the methods I'm telling that every 20 seconds, this is refresh after write time unit seconds, every 10 seconds, sorry, we are going to reload, and every time when we are reloading we will remove what is existing in the cache and we will load with the fresh result. And initially, to start with, we will put a key and the value that you are getting from Hive. So at the time this particular program is started, you will connect to Hive and get the current data and put it into cache, and then every 10 seconds this particular code here will get executed and that cache object will be overloaded. And what I'm going to do is that just to simulate it, I am telling the program to sleep for 30 seconds so that we get 2 times the value that is available from Hive, and always I want to make sure that the cache is getting refreshed with the latest data. So again, I'm going to go back to another command prompt. Let's close this prompts where the Hive server 2 is running. I'm just keeping it there, and then let me start Hive. Let's create a simple table, okay? And we'll create a table with 2 columns. So create table, let's call it as sample, and inside this I'm going to have one column called name, which is of type string, and another column, let's say address, which is also of type string. So it will create a table called sample, and if you look at show tables, by default you are in the default database. You can see that the sample table is created, and let us write insert into values, insert into the table sample values. Let's take passion bytes, and the address is, let's say, Jacksonville. Obviously, since it is not a simple fetch and it is inserting and changing the underlying HDFS, you will be getting a MapReduce program which necessarily inserts the values that we gave here, passion bytes and Jacksonville. So if I do a select star from sample now, you can see that I got passion bytes and Jacksonville as my data. Now let's come back to our code, the other window. Go to the Hive client.java and make sure that you are changing the name of the table here with the table that you have created just now, in order to make sure that we are testing it correctly. So I'm going here and I'm going to write the name of the table is sample, right? And once you made these changes, what you can do is you go to the directory where your maven pom.xml is there, and then write mvn clean install -d skip test equal to true. This will skip the tests because I'm pretty sure that this particular code is directly getting the data and printing it. I have not written any test cases, so we don't have any tests to execute. So give some time until it is downloading all the data and getting compiled. All the dependencies will be brought into your .m2 as per maven, and then if the code is correct, you are going to get a build success as the statistics of this particular command. Alright, Once the build is successful, what you need to do is that you can observe that it is creating a target directory. Maven will create a target directory which contains the jar file that we want to run. So java -jar, and inside the target I have got a file with the name dependencies, hive in cache jar with the dependencies.jar, and already in the maven pom.xml, if you observe, you can see that the main class name is cache test, which is being configured already. So when you run this, what happens is that it is going to create an instance inside the cache which contains your data. So hold for a minute until it is printing all the values. And what I will do, I will make the insert command ready, and this time I am going to insert another value, let's say passion, and this time let's write the city name as Atlanta. Okay, I'm not executing it. Come back here. All right, it got this particular values. Now I am going to execute this particular wing. So I have got 2 rows now, which is now containing passion, Atlanta as well. So let it execute and come back here, and let's wait, because in the code after 30 seconds, as you have seen, it is going to refresh the data. And please look at that. When it is refreshing the data, you got passion Atlanta as well. And look at the size of your cache, it is 1, which means that the old instance was evicted, removed from the cache, and the new instance came in, and the new instance is containing the latest data. In Google Guava Cache, you can evict or remove by either time or weight or size of the cache. We have used here time-based eviction. And this particular code can be exposed to any REST APIs or any reporting applications in order to give you the latest data from your Hive in a near real-time manner. Now, you might think that the MapReduce is a little bit complex process which is taking time. Can you avoid MapReduce and make sure that the cache is getting the refreshed data without executing that MapReduce? Yes, that's possible. If you are changing the code inside the Hive client without using the Hive JDBC connection, but you use the Presto JDBC connection, then Presto will not be using a MapReduce to execute the data from Hive. It will be much faster, and you may get a very fast refresh of your cache rather than waiting for an entire MapReduce to get executed. Thank you very much.